In terms of components, we've got one red LED, one green LED, two 220 ohm resistors, and one ultrasonic distance sensor. Our ultrasonic distance sensor has 4 different pins. First one, VCC, I've got connected to the 5-volt pin. Second one, trig, I've got connected to pin 9. Third one, echo, I've got connected to pin 10. And then the fourth one, ground, I've got connected to the ground cable. This yellow wire is connected to pin 11, which connects to this 220 ohm resistor, which connects to this red LED, which connects to this negative terminal over here, which connects to the ground. This ground cable, since I put my green LED on the other side, I must connect it over. So I've got this green cable connecting to the ground from this side to this side, and then that exact same wire connection that's put over here is mirrored on this side, except this green wire is now connected to pin number 12. In terms of components, we've got one red LED, one green LED, two 220 ohm resistors, and one ultrasonic distance sensor. This is a much easier representation using Tinkercad. Only difference I've made here is that I put both the red LED and the green LED on the same side, so there's no wire connecting this negative terminal to this other negative terminal. Firstly, we define our pins. These are all constant integers as they will not change throughout our code. Red is connected to pin 11, green to 12, trig pin to 9, and echo pin to 10. Then we have our distance defined as a float. This allows us to get decimals for our distance, and then our duration set to long. This allows us to get very large values. In our void setup, we have our pin modes over here where we set our red LED to output, green to an output, trig pin to an output, but our echo pin as an input, as our trig pin shoots out bursts of ultrasonic waves and our echo pin receives those ultrasonic waves. Then we have our serial begin 9600. In our void loop, we first have digital write trig pin low, delay by 2 microseconds, then trig pin high. This releases the ultrasonic waves burst, then delay microseconds by 10, and then trig pin low. This is all that our trig pin does over here. Then we have duration pulse in echo pin high. This detects when our echo pin receives these ultrasonic waves. And then over here, you can copy this into your code. This basically uses the speed of sound in microseconds to be able to find our distance from our duration. We just print this out as a distance, print distance, then we delay 100 before repeating this entire process. Over here we have if distance is less than 10, you can obviously change this value, but this value is what works best for me just for this temporary time. Obviously in a real world scenario, you would not have your cars 10 centimeters above the ground. So this would obviously be changed. Then we have our red pin high and our green pin low. So this basically just turns on our red pin. Else, which means if it's larger than 10 centimeters, then we have our red pin low and our green pin set to high.